Hi, kiddos. Last part of Unit 4. So the last new thing you're going to learn before fall break is about this lovely man named L'Hopital, spelled as you see up there with red squiggles under it because it's not English, it's French. Sometimes you can also see it spelled this way, so don't be upset if there's an S sometimes. It's not a typo. So L'Hopital is a limit-taking technique. So we're back to August or July, I suppose, when we were taking limits. But L'Hopital is a way that we're going to take limits of indeterminates. Curious if you remember what indeterminates are. So these are indeterminate forms. Do you remember we talked about indeterminates? I assume you're nodding right now. And the word indeterminate means keep looking. So before we dive into L'Hopital, let's remind ourselves what those forms are. There are 7. You need to know them because L'Hopital is a really, I'm not being rude, it's a really easy technique. It's a really easy way to take a limit. But if you don't even know that you have an indeterminate, you won't even know to do it. So your indeterminate forms are 0 over 0, infinity over infinity. Those are the 2 that I hope you remember from July. Especially, well, I guess we did both of them, so not especially anything. The other 5, so those are your 2 quotients. You got 1 difference, infinity minus infinity. You got 1 product, 0 times infinity. And then you have 3 exponential. So 1 to the infinity, 0 to the 0, and infinity to the 0. Those are your 7. You must memorize them. Please put them in your memory. There's not like a derivation for them. You're not going to have a way to find them if you don't know them. So please make sure you know them. All right, here's how you L'Hopital. First, you may only L'Hopital if the indeterminate you have is one of these 2. That's it. So the other 5 we are going to talk about, but you can only use this specific technique if you have a 0 over 0 or infinity over infinity. So what you're doing is you're taking a limit, x is going somewhere, you have some function over another function. It's got to be a quotient. And that function over function has to be a 0 over 0 or infinity for this to work. Here's how you L'Hopital. You're going to love this. First, you put an equal with a little h for Hopital. Then you're going to take the limit. Instead of taking the limit of a function over function, you're going to take the limit of the derivative of the function over the derivative of the function. Not a quotient rule. No yodeling involved. You just take the derivative of the top, derivative of the bottom. And then you stop and reassess. So you're going to plug in again, step 1, plug in. And that's what you would end with. That's a parenthesis. If you need to L'Hopital again, you can do it again, and then you'd have a second derivative over a second derivative, and that's fine. Sometimes it takes 2 or 3 lopes to get to your final answer. So let us practice some questions. Let me scroll. Here's what they look like. Limit as we go to 1 of something very simple. This. So again, L'Hopital is super easy as long as you can take a derivative, and most of you can. But you have to show your work very thoroughly. When I graded AP tests in June, L'Hopital was on one of the questions I was grading, and they were very strict about the work you had to show. So you've got to come down here, and you've got to be like, hey, this numerator, when x is 1 minus 1 is 0. Oh, hey, this denominator, when x equals 1 minus 1 is 0. And so this is a 0 over 0. Please note, like the thing that's going to make them crazy and will not grant you any points, even if everything else is perfection, you cannot write equals 0 over 0. Like there should be no equal sign leading to your 0 over 0 anywhere on your paper. So don't do it. Okay, so now that we have shown that this is a 0 over 0, it means it's able to be L'Hopital. We can apply L'Hopital. It's L'Hopitalable. I always put an H over so that the person reading my work knows that I'm doing L'Hopital. And now we're going to take derivative of the top. Derivative of x squared minus x is 2x minus 1. And then we're going to take derivative of the bottom. That's 2x. And then we're going to stop and reevaluate. So back to step 1, plug in. 2 minus 1 is 2. No, 1. And then 1 times 2 is 2. So that answer is a half. Done. The end. Next question. I do want to show you, like, everything you've ever learned is still true. This is not one of those times where I'm like, remember all that stuff we did? It was worthless. It's not worthless. That's a 1. This is the same question. If it were July, I could have given you this question, and you would have come up here and you would have factored out an x. I mean, maybe. I don't know why I'm struggling. I'm sorry. And then you would have come down here and you would have factored a difference of squares, hopefully. And you would have canceled these, reduced them to 1, I hope. And you would have said this equals 1/2. So all of your algebra techniques, your conjugate, your factoring, your making a common denominator, all those algebra techniques still work. They're still fine. This is just another technique. So, and I couldn't teach it to you back in July because you didn't know what a derivative was back in July. Okay, but then you also have some functions where all of your algebra techniques don't apply. Like your algebra doesn't apply to this question. So x, when x goes to infinity, it goes to infinity. This is a strange one to write. E to the x is x goes to infinity, goes to infinity. So this is an infinity over infinity, which means we can L'Hopital. Great, because none of my algebra applies. So when I L'Hopital, derivative of x is 1, e to the x is e to the x. And now what I have is 1 over a very, very large. It's 1 over infinity. I don't want to write it up here. So 1 over big is small, and that goes to 0. That's it, guys. I mean, that's all of L'Hopital. Here's where you're going to mess up. So I said it, but I'll say it again. Sometimes you're going to do a L'Hopital, and like you'll get here and you'll still have an indeterminate. It'll still be 0 over 0 or infinity over infinity. That's fine. That's not a problem. Just do it again. If it never, I mean, I've done questions where you have to L'Hopital 3, maybe 4 times. I mean, if you're at the 4th and it's not getting better, then you should back up and check your derivatives. But here's where you're going to mess up. So this is a limit. Let's go to infinity again. This is x times the sine of pi over x. You're going to mess up a couple different ways. One of the ways you're going to mess up is you're just going to start L'Hopitaling everything. And you can only L'Hopital if you have already a 0 over 0 or an infinity over infinity. This example down here is clearly not ready to be L'Hopitaled because it's not even a quotient. But if I step 1 plug in, x is infinity, sine of pi over infinity. Let's pi over infinity, pi over big is small. This is like the sine of 0. So this is infinity times 0. That is an indeterminate. Yes, it is. That's one of my 7. I have them memorized. It's just not L'Hopitalable. So you have to force it to be L'Hopitalable. You have to rewrite it first. And you get to pick. You got 2 things here. One of them needs to go to the denominator. I have my reasons. I don't know if you trust me. It doesn't matter right now because you can't tell me otherwise. This is the one I want to move. And I don't just throw it underneath and call it x. I have to keep the equation true, like it's an equal sign. But when I do this, I have created a 0 over 0 now. Like the sine of pi over x was still 0. That didn't change. But when I throw that x underneath and call it x to the negative 1, 1 over x, 1 over infinity is also now a 0. And now this can be L'Hopitaled. Might as well. Let's do it. Why don't you pause, try to take a derivative, careful your chain rule. Okay, unpause. Did you? I wonder if you did. I'll never know. Derivative of sine is cosine. Leave the inside alone. Inside here is like a pi times x to the negative 1. So you've got a chain rule to do. So let's see. I pull the power and I subtract 1 over, no quotient rule here. It's just a negative x to the negative 2. It's easier than quotient rule. Please don't quotient rule these things. If you plug in right now, you're going to still have an indeterminate. So like, let's go big picture. Look at what happens. These x to the negative 2's reduce themselves down. These negatives reduce themselves down. So I just have that left over. Let's talk about the cosine of pi over huge is cosine of 0. Well, that's just 1. And don't lose this pi because that is our answer. It'd be 1 times pi. Okay, so this is why I made the decision back here to pop the x underneath, is because I saw 1 over x and I created another 1 over x so that they would match. When I took their derivatives would also match and they would reduce down. So these are one of those things you got to do a lot of, but then you get good at like seeing the future and seeing what they're going to turn into. All right, that's day 1 of L'Hopital. Just to prep you for what's coming. If I had an infinity minus infinity indeterminate, those are really quick to turn into L'Hopital questions because I would just do a common denominator and put them together. What's going to take us some work are these exponentials. So that's what's coming tomorrow. All right, kiddos. Let me know if you need anything.